Welcome to the session on GKE Networking Differentiators. Oops. Hello. I'm Manjot, Product Manager on GKE Networking.
And I'm Pavithra, Software Engineer on the same team.
Today we'll be discussing how GKE Networking helps your business grow by catering to your needs of scalability, security, load balancing, and visibility.
Here are some of the features we'll be talking about today. On the topic of scalability, we'll see how VPC native and optimized IP allocation can help scale your clusters.
Security features like config time shared VPC, network level features like private clusters and master authorized networks, and application layer features such as Cloud Armor and managed SSL certificates.
Learn how you can optimize your web applications with container native load balancing. And finally, we'll talk about some visibility features like intra-node visibility and VPC flow logs that will help you analyze your deployments. A quick reminder here, you're welcome to post your questions as we are going through the content in the slides. You can do this online through your Next app. Just go to the Next app, pick our session, HYB217, and click on Dory Q&A. Post your questions, or you can upvote an existing question if you want us to answer it. Looking forward to that. Thank you. And for this session today, we're going to do something different to go over the benefits of GKE. Manjot and I are going to put ourselves in the shoes of network admins/architects at a fictitious enterprise company. This enterprise runs a popular web application. Given this is tax season, let's pretend this is a tax filing application. This app got hugely popular due to its easy-to-use interface and unbeatable price. Who wouldn't want that, right? Now, this enterprise is starting to use GKE to scale up their service. And we are here, the network admins, brainstorming our architecture.
I'm the skeptic who is unsure whether GKE would match up to our needs. And Pavithra is the advocate who just attended a workshop and learned about all the cool features that GKE has to offer. Now let's begin our story. We have the best problem you could have, massive demand. We know that we are projected to get several million queries per second, especially closer to tax deadline. We need to have a clear plan and sketch out our architecture, especially the networking. We would like to proactively tackle our scalability challenges. Can GKE match up to our needs?
Let's talk through it. What's on your mind?
You know that we already have a GKE cluster with several hundred nodes. We're obviously using ingress-based load balancing to expose our services, and we have a single virtual private cloud to protect our deployments and have a secure boundary around it. My first concern is around the size of the deployments. We know that as we build out many features into our application, we would need more nodes, a lot more nodes. We know that for sure we would be reaching maybe even up to 1,000 nodes in our GKE cluster. Can GKE, how do we even manage networking for such large clusters?
Let's think about that for a minute. As the number of nodes increase in our clusters, the number of routes and number of IP addresses become important. We should start by creating our clusters as VPC native clusters. In this mode, cluster IP addresses come from 3 different ranges. The first range is called the node range, or the primary range of the subnet. This is used for assigning node IP addresses, the IP addresses for all the cluster nodes. There are 2 secondary ranges as well. One is the pod range, and then one for the services. Now, each node uses the pod range and takes a smaller slice for assigning to pods that are running on itself. So you get a smaller slice of the pod range on each of those nodes. Now, these pod ranges use something called alias IP addresses, which are natively routable. This means the logic to route them is built into the networking layer, and there is no need to configure any additional routes. Contrast this with the advanced route clusters that need a route for every node we create on them. We can easily scale up to 1,000 nodes with VPC native. There are additional benefits to running clusters in this mode. Firstly, the networking layer performs anti-spoofing checks to make sure workloads are not sending packets with arbitrary source IP addresses. Second, the VPC is global, so we can create clusters in different regions like US West, US East, and all those clusters can talk to each other without having to do any peering on our side. Another benefit that GKE provides that's relevant here is that the master VM is automatically scaled up to match the cluster's needs. It is also automatically upgraded, secured, and backed up. Can you imagine how useful this will be when we might need to repeatedly scale up our clusters as our needs grow? It's one less thing to worry about.
I had come across VPC native as well. Well, as you mentioned, we know that every single node is assigned a pod range from which IPs are picked up and allocated to pods running on that node. And we know that the default for every single node is a /24, which roughly translates to about 110 pods per node. Now, I know for sure that we won't even be close to 110 pods per node. We don't need that many pods on every single node. Moreover, some nodes might actually have fewer resources, which means even fewer pods. I'm just worried, how will we manage our IP space more efficiently using this scheme?
What you mentioned does seem like a problem. You're right that by default, every node gets the setting of 110 maximum pods running on it. This means under the hood, it is assigned a /24 CIDR range. And multiply that by 1,000 nodes, that's a lot of IP addresses, especially if you're not going to use them. Luckily, GKE does allow us to optimize IP allocation. We can do this by modifying the maximum pods per node setting. This can be done on a per node pool basis. We can put all the nodes with smaller resources into their own node pool and manage this setting, modify this setting to a different value. Say we set it to 8. The maximum pods per node is 8 for the smaller node in their node pool. That would make the nodes get a /28 instead of a /24, which is already significant IP savings. Another thing we could do is that the pod range and the node range can be shared between clusters that are in the same subnet. So then this lets us save even more IP space.
Interesting. That seems to work for optimizing our IP allocation, but I have a greater concern. What about security? Our application handles user PII data like social security numbers, tax details, payment information. Identity theft is a very real concern. We need to make sure that our users feel very safe sharing their sensitive data with us. How do we restrict access to our workloads? How do we ensure that some random person over the internet, or any unauthorized IPs don't get access to our clusters? You know that compliance is such a big concern. Compliance is a deal breaker.
I'm glad you brought up security early on in our discussion. There are a few things we can do here. We can start by creating our clusters as private clusters. In this mode, the nodes in the cluster do not get a public IP address. That means they're isolated from the internet. The communication between the cluster nodes and the master happens over RFC 1918 addresses, which, as you know, refers to an address space that's completely private and not routable on the internet. Enabling this feature is as simple as checking a box when we create the cluster.
That sounds good for the workloads. We should make all our clusters private clusters. But gaining access to the control plane, what do we do about that?
I had a hunch you might ask this next. There's a solution for that as well. It's called Master Authorized Networks. With this feature, you can specify IP address ranges that are whitelisted to talk to the master node. In addition to creating or originating a connection from a whitelisted IP, one also requires credentials to log on to the master node. That is security in layers, known as defense in depth. Like we talked about, when you create a private cluster, you automatically get a master authorized network with a default deny whitelist, which means no IP addresses can talk to the master node.
Didn't know about that. That seems pretty useful. Speaking of access to clusters, we need to build a lot of features, like tracking tax-deductible donations, enabling you to import your W-2, etc. So, for example, we obviously have our core tax filing team and our W-2 importing team. Now, ideally, these two teams can independently create and manage their clusters. But we know that for sure, they do need to share a certain set of network resources, such as firewalls, routes, etc. Ideally, what should happen is those network resources should be controlled by us, but our teams can still create clusters independently. How do I ensure that these clusters can communicate with each other without the need for additional VPC peering? How do I ensure that my teams are isolated, the network resources are managed by us, but the teams are still agile?
Let me make sure I summarize the problem right. We have the few requirements, right? Firstly, we have individual feature teams that want to create their own clusters and manage them independently.
Yes.
Second, these clusters will still use network resources that we maintain. We, as in network admins, maintain and have total control over. Third, we want these clusters, these team clusters, to be able to use those resources but not modify anything. Like no organization level changes can be done, no modify more than what they need to use. And last, we want all these clusters and their workloads to be able to talk to each other. 4 requirements, right?
That sounds about right, yeah.
Right, awesome. So this is exactly what the feature called Shared VPC solves. With this feature, the network admins can manage centrally all the network resources like load balancers, subnets, routes, and firewalls. All this management happens in what is known as the host project. Individual feature teams will create what are known as service projects, which will have use permissions on all of these resources. The team's clusters reside in those service projects, and they will not be able to modify any of the critical network resources. Like, you can't have the W2 team go and delete a firewall rule, for instance. We have that isolation. And finally, since all these clusters are on the same VPC, same virtual private cloud, they all can talk to each other without us needing to do any additional peering.
So you mean to say that our teams can create and manage their clusters without the need for, and talk to each other without the need for additional peering, and the network resources are managed by us? That sounds great.
That's exactly what I mean.
We'll definitely keep that in mind.
Cool.
Now let's talk about handling bursty traffic. You know that closer to tax deadline, when everyone's filing last minute, we will get a very large spike in our traffic. Especially also when we're giving a promotional rate to some of our users. How do we ensure that our application continues to serve our users without going down? How do we ensure protection against some of those common web application attacks? We obviously hear a lot about anti-DDoS protection. There might be abusive scripts that try to saturate our network, choking real user traffic. Someone might attempt to shut us down, or worse, try to steal our data. How can GKE help us protect against this?
Very valid concerns. I agree. We must be prepared for the worst when it comes to peak traffic. Good news is HTTPS load balancing, Google Cloud load balancing, specifically HTTPS load balancing, provides some amount of anti-DDoS protection along with the load balancer. When you enable SSL proxy load balancing or HTTPS load balancing, the Google infrastructure automatically absorbs and mitigates several layer 4 and below attacks, such as SYN floods, IP fragment floods, port exhaustion, to name a few. In addition to this, Cloud Armor is our friend. It arms us with the ability to whitelist trusted IP addresses and blacklist abusive IP addresses that might talk to our backends. A flexible rules language to customize our defenses and protect against multi-vector attacks is at our disposal. It also provides defense against web application attacks such as SQL injection, cross-site scripting, and several others.
I see. That looks promising. On the topic of application layer security, we obviously have a lot of domains, and we serve each of those domains using an SSL certificate. So we need to, for example, have it for each of our enterprise customers as well, such as foo.taxapp.com and an SSL cert per one of those domains. Now, we are using a single load balancer, and we are obviously, for now, managing all those SSL certificates manually, which means we need to keep track of things like expiration dates and renew them when they expire. Now, this is a very fickle setup. It can actually cause business loss in case someday we forget to renew them on time. I would ideally like to offload this work to some sort of automation and some sort of management than have our teams manually manage our certificates.
I hear you. I completely hear you. Managing certificates with one-off scripts or by hand is something I have done myself, and it's not fun. It definitely sounds painful. I have some great news for you, that GKE now offers end-to-end, hassle-free SSL management, SSL certificates management. This means you can have your certificate management work offloaded. Certs for domains will be automatically issued, provisioned on the load balancer, renewed as needed, and deleted when you delete the load balancer or cluster resources.
That sounds interesting. Can you tell me more?
Sure. You start by creating a custom resource object for your managed certificate. You just need to put the domain name of the domains whose certs you want managed. Say we want foo.taxapp.com to have certificates automatically issued and managed. Just put that domain in your spec and link it to your ingress spec. Done. Certs for this domain will now be, like I mentioned, automatically issued, renewed, and deleted when they expire. It's not a dream. I'm serious.
That would be a relief for our teams, getting out of this business of manually managing certificates.
You bet. Let's recap all the security features that we talked about just now. Firstly, we talked about network layer security with private clusters and master authorized networks. Then we talked about application layer security with Cloud Armor, easy SSL certs management with managed certs, and secure delegation of resources through shared VPC.
That sounds cool. It seems like GCP puts security first. But I'm still worried about one more thing, latency to our backends. Our app is getting popular, and obviously we are going to get that traffic spike. I'm worried about that. Will our pages take several seconds to load? That will cause a very frustrating user experience for our users. Definitely not something we want to put our customers through.
Tell me about it. No one likes staring at a blank browser screen, right? I recently heard about this feature called container native load balancing that might help us here. What I know so far is this. Container native load balancing allows the load balancer to talk to pods directly and evenly distribute traffic among them.
How so?
Let's talk about what happens without this feature. Without container native load balancing, requests come to the load balancer and travel to the node instance groups. From there, they are routed to the correct matching pod, which might or might not be on the same node. As you can see, this introduces a connection hop. Because container native load balancing talks to pods directly, the connections have fewer network hops, and latency and throughput are improved as a result. There are additional benefits to using this mode. With container native load balancing, you will get to see the round trip time between the client and your backend. This makes troubleshooting way easier since you get Stackdriver UI support as well. Finally, the health checking is improved and is more accurate since it directly talks to the pods.
All this sounds great, but what about when things are not working? What is the visibility and monitoring story here? How do I troubleshoot my deployments?
I was waiting for this one. VPC flow logs can help us there. You can enable VPC flow logs on a per subnet basis. When enabled, this feature collects flow data from every node on the subnet.
But will I see traffic both between two different nodes and on the same node, like intra-node traffic?
Yes, absolutely. You will see traffic between nodes, like we just said. And with a feature called intra-node visibility, you will get insight into traffic within a VM. That is pod-to-pod traffic on the same node. This feature launched just today, so it is hot off the press.
But will it cover all the surface areas?
Every flow is sampled, whether it's TCP or UDP, whether it's between two pods or between a pod and a host on the internet, in your on-prem data center, or a Google service. And if two pods are communicating and they are both on subnets that have this feature enabled, you will see bidirectional traffic between them.
But if it covers all those surface areas, will that add latency to my packets?
That's the best part. Since VPC flow logs is built into the networking infrastructure, there is no additional delay and no performance penalty to routing the logged packets to their destination.
I can't wait to try out this on one of our clusters. That sounds very useful.
Me too.
Pavithra, discussing all these features with you and all these capabilities with you, I think I feel confident that our TaxApp will survive this year's traffic spike. I definitely learned a lot more about GKE and GKE networking today, and I'm confident that we can keep our application running securely round the clock.
I'm so glad I could help, and I agree with you on all of that. Okay, well, that ends our story here, and I hope you all got a good overview of the various networking features on GKE. Let's summarize what we talked about. Once again, with GKE, you can manage and scale your clusters with VPC native and optimized IP allocation.
GKE offers several network security features, such as config time shared VPC for secure delegation of network resources, application layer security features such as DDoS protection through Cloud Armor and managed SSL certificates, and network layer security features such as private clusters and master authorized networks.
Optimize load balancing of your web applications with container native load balancing. Analyze your deployments easily with VPC flow logs and intranode visibility. If there's one key message you want to take away from our discussion here, it is this. With GKE, you get armed with all the tools you need to scale, manage, and secure your clusters. Analyzing your deployments is something you got covered with GKE using the visibility features we talked about here.